So in this video, we are going to be discussing inverse trig functions. So these inverse trig functions are going to be very important for us when we are solving for angles. So a quick breakdown of what an inverse is again. So it's basically when your input and your output switch. So it's also a reflection across the line y equals x. And typically you see it with this -1 notation. So you see the exponent here with a -1. So this is the normal function notation. To say that we have found the inverse of a function, we would say f to the -1 of whatever it may have been. So this is also the same thing with your operations. So if you think about inverse operations, the opposite of addition is subtraction. So those are inverses of one another. The inverse of multiplication is division. The inverse of something being squared is the square root. So it's basically an operation that breaks down the previous function. So when we write these inverse functions, we're going to have our trig name followed by the -1, and then you have whatever is inside. So that is a very important order. So sometimes you may also see it written as arc sine or arc cosine. It means the exact same thing. It's just another way of saying it. So this is going to be very helpful when we are trying to solve for an angle, because again, it's breaking down that function of sine or cosine or tangent or whatever it may be to get us what's inside of it. Kind of like if we had the square root of something, we would square it to get rid of the square root. So it's the exact same concept. So one thing that you need to really understand is the importance of this order, because the sine to the -1 of x does not mean the same thing as sine of x to the -1. The first one means inverse, which is what we want. The second one means reciprocal. So reciprocal of sine is cosecant, and that's not what we are talking about today. So make sure that you understand the difference between those two things. So let's look at some examples. So see that I am trying to solve for x here. So I'm trying to find this x. But currently, I have some function that is being done to x to give me out this output of the square root of 3/2. So I need to get rid of this sine. So what I'm going to do is I'm going to take the inverse sine of both sides, because if you remember when you're solving something, what you do to one side, you have to do to the other side. So I'm going to be taking the inverse sine of both sides. And what that does is the inverse sine of sine is just going to cancel away, leaving me with x, because that's what I want. I want x by itself. And on the other side, this is something I'm going to be putting into my calculator. So in your calculator, try to find the sine button, and then depending on your calculator, you may just need to hit that button again, or you may need to hit second and that button to get to the inverse sine. So again, it depends on whatever it is in your calculator. So I'm going to hit inverse sine. I'm then going to hit the square root of 3. I'm going to divide that by 2, and I'm going to close those parentheses. It is very, very important that you close these parentheses. And if you have an older calculator, when you had entered the square root sign, it would have opened parentheses here. You need to make sure you close those parentheses before you divide as well. So closing off parentheses is going to be very important. 8 out of 10 times, that is going to be your mistake when you were solving one of these problems. You forgot to close off those parentheses, so your calculator didn't know what you were asking for. So I get out 60 degrees because x is an angle. Anything inside of that sine is considered some kind of angle. So let's look at the next one. So I have the cosine of x equals the negative square root of 2 over 2. So again, the thing I'm trying to solve for is inside of the function of cosine. So I need to do the inverse of cosine in order to get rid of it. And again, what you do to one side, you have to do to the other. So I'm going to take the inverse of cosine on both sides. So again, on the left side, the inverse cosine and cosine are going to cancel, leaving me with just x. And on the right side, this is something I'm going to be putting into my calculator. So putting this into your calculator, you're going to hit inverse cosine, you're going to hit the negative, you're going to hit the square root of 2, get out of the square root or close your parentheses, hit divide, 2, close off the parentheses for the inverse cosine button, and hit enter, and you get 135 degrees. So inverse trig functions are going to help us find angles that we're looking for. So let's look at an example where we actually have a triangle and we're trying to find an angle. So here I am given some sides and I'm asked to find the angle E. So I'm asked to find this angle down here. So I know that D was 32, so this was 32. I know F is 17, so this F was 17. So now I need to set up a trig ratio. So I have this angle. So I know that side F is actually the adjacent of that, and side D is going to be the hypotenuse of this triangle, and E is of course the opposite. So I'm trying to find or remember which trig function uses adjacent and hypotenuse, and that is going to be cosine. So this is the cosine of my angle E, because again I don't know that, and that is going to be equal to the adjacent, which is 17, over the hypotenuse, which is 32. So now that we've set up this trig ratio, we can use inverse trig functions to help us solve for E. So again, the thing I am solving for is inside of some parentheses, so I need to go and take the inverse cosine of both sides. So on the left side, the inverse cosine and the cosine will cancel, leaving me with just E. And on the right side, this is just something I put into my calculator. So the inverse cosine of 17 divided by 32, close those parentheses, and I get out 57.91 degrees, because again, this is an angle. Right? We just solved for the angle E, so make sure you hit that or put that degree symbol. So I'm still needing to use that old knowledge of setting up trig ratios in order to then go and find the angle I'm looking for. So I have a U-try, so it is a word problem, which means you're going to need to set up a drawing first to find out where the triangle is located in that drawing, and then solve. So a security light is being installed outside a loading dock. The light is mounted 20 feet above the ground. The light must be placed at an angle so that it illuminates the end of a parking lot. If the end of the parking lot is 100 feet from the loading dock, what should the angle of depression be for the light? So pause this video and try it out. So you should have gotten the angle of 11.31 degrees for the angle of depression. So if you did not get that, make sure that your drawing was looking for the angle of depression of the light.